Okay, this is problem 18 on page 826. It's dealing with expected value. It says 1,000 raffle tickets are sold at $2 each. 3 prizes of $200 and 2 prizes of $100 will be awarded. Assume the probability that any given ticket is selected for a $200 prize is 3 1,000ths, and the probability that any given ticket is selected for a $1,000 prize is 2 1,000ths. Part A, determine the expectation of a person who purchases a ticket. Now, expected value, and there's a formula in the book, E equals probability of event 1 times the net amount gained or lost of event 1 plus the probability of event 2 times net amount gained or loss of event 2 happens, and then so on for as many events as there might be. Now, in our particular situation, the first thing you have to do is figure out how many events are possible here. What are the different outcomes if you purchase a raffle ticket? And the fact is there are 3. You could either win a $200 prize, you could win a $100 prize, or you could not win anything. So there's 3 options here. So let's take them one at a time. The first option, let's say you win the $200 prize. That's going to be event 1. So what's the probability that happens? Well, the problem tells you that's 3 out of 1,000. So that's the probability that you win a $200 prize. Well, what is the net amount won if that happens? And the key word there is the word net. Okay, so it's not $200 here because you paid $2 to purchase this ticket and then you win $200. So the net gain is actually $198. Okay, then event 2, we're going to be the case where you win the $100. What's the probability that happened? It's 2 out of 1,000. Your net gain in that case would be 98 because it's 100 minus the $2. And then lastly, we've got the case of, well, what if we lose? What's the probability that we don't win anything? Well, if 3 out of the 1,000 tickets are $200 winners and 2 out of the 1,000 are $100 winners, then how many does that mean are losers? Well, 5 were winning out of 1,000, so 995 out of the 1,000 are losing tickets. And your net gain in each one of those cases is negative $2. You just lost $2. So you type all that in the calculator, and you're going to get negative 1.2. That's what it shows on the calculator. But this is dealing with money in this case. Our expectation is money, so let's report our answer as negative $1.20. That's your expectation if you purchase this lottery ticket. So don't expect to win. It's the same thing with other types of lotteries. Your expectation is not positive, or they wouldn't make any money. Part B, determine the expectation of a person who purchases 3 tickets. Okay, if you purchase 1 ticket, you can expect to lose on average $1.20 each time you purchase a ticket. So if you purchase 3 tickets, your expectation is negative $1.20 times 3, so negative $3.60. The more tickets you purchase, the more negative your expectation, unless of course you buy up all the tickets. But then you still come out negative because the amount of money you spent is going to be worth more than the amount of money you'd win. And lastly, part C, determine the fair price to pay for a ticket. Fair price, it's by a formula in the book, fair price is equal to cost to play plus expectation. So in our case, the cost to play was $2, and we found out the expectation was negative $1.20. So we add those two together and get 80 cents. But you will not often find tickets sold for their fair price, because usually the object is for the person selling the tickets to make money. If they were sold at fair price, then they wouldn't make